Hello everyone, this is Yu from class EL6303. In this video, I will solve question 2 in homework 6. So for this question, we are given the information that the joint density function of x and y is fxy xy equals to b, and x squared plus y squared should be less than 1. And this joint function, density function, will be 0 in other conditions. So for the first question, we need to find b, so that the above the defined function is a valid joint density function. And according to the definition, that if this joint density function is valid, it should have this form. That means if we integral from minus infinity to the infinity, fxy xy dx dy, it should be 1. So we know about this equation. This equation, we can draw the diagram like this. It's like a unit circle, but the shaded part in this unit circle is our ranging. So let's check out this part. Means it's the area. The area of this part should be pi, so we can get pi times b equals to 1. So b should be 1 over pi. This is the answer for part A. For part B, we need to find the expectation of capital X, the expectation of capital X given by y, and as well as the expectation of capital x given by capital Y, and the expectation of capital Y, as well as the expectation of capital Y given by x, and the expectation of capital Y given by capital X. Also the expectation of x and y. First, let's check out how to figure out the expectation of capital X. So according to the definition, it should be in this form. To do the integral from the minus infinity to the infinity, x times the joint density function dx dy. So that means we just plug the b in here, and we can get the answer should be 0, because this question is a odd function. So let's check out the other one is the expectation of capital X given by y. So we should do it like this. To do the integral from the minus infinity to the infinity, and x times the fx given by y dx. So it should be in this form. It should be the integral from the minus infinity to the infinity, x times the density function x and y, and over the marginal function fyy dx. So let's see this part. If we multiply this part, we can get the expectation of x. We just got it from this part, so it's 0. Clearly, this part should be 0. And that means the expectation of x is for every y. Every y is 0, so we can get this part is the expectation of capital X given by y should be 0 for every y. Then we need to solve the expectation of y. Y is equals to 1 over pi. To do the integral, we just use the boundary from the minus the square root of 1 minus x squared to the square root of 1 minus x square, and the y ranging is from minus 1 to 1, and we should do the integral for the y dx dy, because this is also the odd function, so it should be 0. And after that, we need to do the expectation of y given by x. So we also need to do the integral from the minus infinity to the infinity y times the joint density function of x and y, and to divided by the marginal function fx x dy, and it's also we got is 0, so it's for every x. So clearly we can get the expectation of capital Y given by capital X is equals to 0. And for the last part is the expectation of EX and Y is should be to do the integral from the -1 to 1, and this is the Y range, and from the minus square root of 1 minus x squared to the square root of 1 minus x squared xy dx dy times 1 over pi. And this also is the odd function is symmetric from the original part. So it should also become 0. So for the part C, we need to prove or disprove x, the random variable of x and y are uncorrelated. We should know the value of expectation of x, y, and the expectation of x as well as the expectation of y. We already did it from the part B. So all of them are equal to 0. So this equation is equal. That means the random variable x and y are uncorrelated. Thank you. This is the answer for question 2 in homework 6.